Hello, everyone. Welcome to another evening of Shaper Sessions. Today, we have something very exciting for you and very long loved and asked for. We're going to focus on dovetails.
Hey everybody, hopefully you can hear me okay. Joining you from home this afternoon. As Jake mentioned, we are sort of rolling back to the old days for the time being. So hopefully there are minimal technical issues, but bear with us if there's anything funky. We are kind of back to duct tape and string for the time being. But here we are, and I am really excited today to talk about dovetails. As Jake mentioned, it's something that we have been asked to talk about for sessions probably since more or less the beginning. People are really interested in this topic, and we are hoping to deliver some really good content to you today. One thing that's very exciting, and we'll get into it a little bit later, but we do have kind of a cool project that goes along with this session, and we'll get into that in a little bit, and that should help you actually create the files for your dovetails, which in all honesty is kind of the hardest bit. Dovetails, beyond the kind of figuring out how many you want and how wide the work is and dividing that all evenly, that's kind of the challenging bit. Actually cutting is pretty straightforward. There are a couple of little tips and tricks and pitfalls we want to talk about, but in general, should be straightforward and should be a fun session today. So let's get rolling. We'll go ahead and get ourselves right on in to the slides, and it'll be a quick deck today. All right. As we mentioned, dovetails with Origin Workstation. Origin Workstation are made for each other on this kind of in joinery. This is really the bread and butter of the combination. So whether you've got a home built one or a Shaper Workstation, you're good to go, though obviously the Shaper Workstation is going to be a more accurate kind of approach to some extent. And then the other important thing that Jake is going to talk about a little bit later is that it is really important to be able to align your work on the left hand and the right hand side for this project. And he'll talk a little bit about why that is. But in sort of opposition to what we normally talk about with box joints, where we say it's actually the same, but it's conceptually a little different. You're picking a reference edge and you're sort of trying to set your grid up off of that edge always. And that allows you to soak up any inconsistencies in your material width. It means that one side of your box always lines up flat. The other side might be a little bit proud or a little bit short, but at least you're not dealing with proud or short on both sides of your project, which is much more difficult to deal with rather than having one good surface that you can reference and plane or thickness sand or whatever floats your boat. So a dovetail, for those of you that don't know, is a method of in joinery that uses an overcut to make the joint captive. That overcut also allows for a little bit more surface area for glue than a box joint, and it looks really cool. There are potentially some other advantages that I'm not mentioning here, but I think the reality is the main advantage is that it's a sort of captive undercut and allows for the box to stay together mechanically a little bit better than a box joint does. If the glue fails in a box joint after some time, there's nothing really holding it together mechanically from busting apart. With a dovetail, that is not the case. It's held together from pulling apart mechanically in one direction, so in the direction that the undercut holds it. So as you can see, this is the four sides of a dovetail box. We've got a couple different methods that we use to cut dovetails with a router. We're going to use two different kinds of cutters. We're going to use a dovetail mill, so we'll see kind of an image of that in a second, and we'll be using an end mill, which is just the standard kind of router bit cutter that ships with Origin that you should be familiar with, a square end mill. And we'll get after it. So we can go ahead and move on to the next slide. So as I said, two different mills, and you can see that there sort of are two disparate parts to a dovetail joint versus a box joint where the parts are relatively similar. We still sort of call them pens and tails inside at Shaper. I don't think that's particularly correct. It's just an easy way to talk about a side A and a side B. With dovetails, that is literally pins and tails come from the dovetail joint. The side that's cut with the dovetail mill that has an undercut, that is the tail side, obviously, the dovetail. And then the pin side slots into the dovetail at 90 degrees. So both of these are milled on end in a workstation, but we achieve that undercut by using a tapered profile, an outwardly tapered profile cutter, which is on the left-hand side there. And on the right-hand side, we have the end mill, which matches that profile at 90 degrees. We can go ahead and go on to the next slide. So a few common bit sizes for dovetails in the States. You have, and what's going on here is the degree references the taper angle of the dovetail. What's important to remember here is that the taper angle is off of the center line of the bit. It's not actually the inclusive degree angle, or inclusive angle rather, taking into account both sides of the cutter. It's actually just from 90 degrees outward. So that's important to remember. It's a lot of the boxes for dovetail cutters have a little graphic on them showing you how they're measured. When we get into building the file here in a second, or generating the file rather in a second, you'll see that the sort of nominal angle reference that usually is quoted on a dovetail bit is what you want to enter there. So for today's session, we'll be using a 14 degree by half by half. So the next little bit of measurement on there, just to kind of talk through the anatomy of a dovetail cutter. I wish I had a drawing here. That's one thing I didn't put in, I'm realizing. But basic idea is that first measurement, that 0.5 inch, is the diameter at the bottom of the dovetail cutter. And that's an important one for us with Origin because that's what we're going to enter as the bit diameter value for cutting these dovetails. It's really important because that's the greatest diameter on the bit, so you want to make sure that Origin's doing its offset magic properly, referencing that diameter. Certainly can't hurt to get your calipers out and actually measure that dovetail cutter, just to make sure that what it says on the box is what is going on in reality, because with Origin we're working in quite tight tolerances, so being sure that the manufacturer of the bit isn't sort of fudging anything there is a good idea. So that's the first measurement in from degrees. That's the bottom diameter, and then the top, or the most right-hand measurement is the length of cut. That's what LOC stands for. If you're confused on any bit sites, it's length of cut, and so that is the measurement from the very bottom of the bit to the topmost cutting geometry on the bit. So the bit extends, and where the bit extends beyond the cutting geometry rather, is called the shank. You can actually, if Ted wants to link out to it, we have done a session on materials and cutters. Sam did that one a while back, and it sort of explains all this in a little bit more detail than I'm able to go into today. But anyway, that's length of cut, and Sam's video might make that more clearer than I have. He's got good sort of teaching aid graphic illustrations to make that clear. But what's important to know about that length of cut is that you cannot make your dovetail any deeper than that length of cut. So the material that you are cutting your dovetail out of cannot be thicker than the length of cut of your dovetail bit, without some pretty aggressive math. So I would just say it can't be thicker. So whatever you're doing there, make sure that the dovetail that you buy has a length of cut that is appropriate for the thickness of your material, i.e. Equal to or greater than the thickness of your material. Yeah, and of course it's an angle, a taper angle, which is a little bit fun. A 14 degree bit that's got a half-inch length of cut, if you get a 14 degree bit that's longer, the bottom diameter is going to have to necessarily be wider. So you want to also make sure that the width of the dovetails that you're trying to cut is appropriate for the cutter that you selected. So like I said, there are a few things to watch out with the cutters, but in general, if you're trying to make drawers and you're dealing with, say, like 1/2 inch or 3/4 inch material. You can see that 8-degree mill has a 0.8 inch length of cut, and so 3/4 of an inch would be fine for that. So it's gettable, and just generally going by those rules of thumb, unless you're making something crazy, should get you by. So we can go ahead and go into the next little bit here. Okay, so here is probably the #1 reason why we've been reticent to talk about dovetails with Origin. There is a pitfall. Origin is constantly looking out to make sure that you're not going to make a mistake, i.e. going out of bounds of the profile that you've told it you want to cut while you're cutting. If you do go out of those bounds of that profile, Origin actually will retract, right? Because it's trying to stop you from making a mistake. And in almost every circumstance, that's super helpful. However, in this particular circumstance with a dovetail mill or with a key slot mill, anything that has an undercut profile on it, it's actually detriment, because if you screw up a little bit and Origin feels like it needs to retract to save your workpiece, what it's actually going to do is retract straight up and out, and the undercut from your mill is going to cut straight up through your nice dovetails, as you can see on the right-hand side, and that's going to suck. That's going to make that particular piece pretty useless to you. So Jake will talk a little bit more about this, but it's really important to stay in the game, stay focused, and really pay attention to being careful while you're pocketing, as well as profiling these dovetail undercuts with the mill, because you could very easily just slightly stray out of bounds or hit a little bit of differently grained wood or a knot or something, and it could retract on you, and that's sort of bye-bye for that part. So just be careful. Practice on materials you don't care about, and that's a good theme to talk about here. Grab some plywood, grab some poplar, whatever, and just make sure that you're comfortable before you go pulling out the good stuff, because I really don't want to be encouraging you to make dovetails and then have you have a terrible experience where you ruin a nice piece of lumber for no particular reason. So we can go ahead and move on. Hopefully I've driven that point home, and we'll go ahead and actually switch over to my screen now, if you would, Goose. Look at that, the magic. Okay, so this is the project that I was alluding to earlier that is created, or rather was created by me for this session, for you guys. You're welcome. This is sort of the answer to, hopefully, some of your prayers for making dovetails. It is a generator that, it is a generator that, Goose, you might want to turn the gain down. It looks like on my screen it's a little bit blown out. It's a generator that creates geometry for a dovetail. The cut files, the Origin cut files, and it also, similar if you've used the box joint generator on Origin, the box joint basic extension, it makes the overcut areas as well, and those overcut areas are really important because these joints have clear shoulders, meaning that you have to allow the cutter that you're using to go out past the edge of your material by its radius, or even a little bit more, just to be safe, so that you get a flat shoulder all the way through, so that you can mate them together and they do their job. If you didn't do that, Origin would assume that it's sort of little inside corners, little rectangles, and it wouldn't let you clear all the way through, and it wouldn't work. So this generator is really important. That overcut geometry that I was talking about is really important, and you'll kind of see why as we go along. But I put some instructions in there. They may or may not be clear as mud, so hopefully this video will also get thrown in with the instructions and help make awesome dovetails for the community. So things you'll need: Autodesk Fusion 360. That is a limited version of it is free to hobbyists, but you can still get by. And the Shaper Utilities plugin for Fusion 360, which there's a link on how to install that here. So that's kind of what you need at first. but we're not going to look at installing Fusion. We're just going to kind of jump right into how you use it. But in order to get the file, you can't download it from this page. You must hit copy to my Origin files, and once it's there, you can click this button that says go to your files. And now I can open up the Dovetail generator folder and click the download button. Now I have the Dovetail generator downloaded. Okay, that's just clearing that up because it is a little confusing that you can't download it directly from the project page. Okay, so we're going to scooch over to Fusion here. This is what it looks like when you open the file. And I tried to make this as really as simple as possible. And so all you have to do when you're trying to make a box joint is open the file, click on this modify menu, go to change parameters here, and that's going to open up this window. And this is one of the photos in the project that you'll be able to see, so you should recognize it. And what's going on here, and let me just drag this around a little bit so you can see the full names of things. What's going on here is every one of these parameters is associated with some part of the Dovetail model behind the window. Okay, so, and hopefully these names are pretty clear, but I did list out in the, let's see if we go back, I did list out what all of those parameters do here, if you're confused. So in the instructions for the project, they are listed out there and you can read about what they do. The material width should be obvious. That is the width of the board that you're using. So if it's a drawer, it would be the sort of height of that drawer, but this is the width of the board that you're using. The thickness of the board that you're using, material thickness. So in this particular instance, it's an 8-inch wide by 0.5 inch. I think Jake may be using 6 inches wide. So I'm just going to go ahead and what we'll see here is if I update this value and put 6 in and press enter once, it's going to make it all narrower, like magic. Okay, and there's a couple other things we can do. We can adjust the angle of the dovetail mill. So like I said, if you're, say, using an 8-degree mill instead of a 14-degree mill, put 8 in there, hit enter, and it's going to update to 8 degrees now. We'll put that back to 14. Okay, and then the dovetail count should be kind of obvious. It's how many tails you're going to make. The pins will always be one more than the tails. The tails are an odd number, and you can see I put in the comments here, these have to be an odd number. It's got to be an odd number. It will break the model to use an even number, so use an odd number. So maybe we want it to be a little bit wider. I'm going to hit 5, and it will update. You can see now there are 5 tails. And what's important to note about this file is there's no control over the actual width of your tails or your pins. They are divided evenly from the center across the width of your material, across this material width. So there's no way to control the size of them. They're just going to distribute themselves evenly by this count that you give it. So that is certainly one of the limitations. If you want to really control what size your dovetails are, this is not the model for you, but you're welcome to download it, see how it works, and fiddle with it, make changes. Other things, let's just blast through this quickly. It's really important to put in the diameter of the end mill that you're using. So Origin's cutters in 1/4 inch is fine. And then also the dovetail mill diameter, and I note here it's the diameter of the widest end of the dovetail mill. So important that that's the widest end, not any other diameter measurement. And this edge overcut, I'm not really going to talk about a ton. You can read in the project to see what that value does, but you probably don't need to touch it. So there we are. Once I'm happy with these settings, which I believe I am happy with these settings, I'm going to hit OK. And then I'm going to go over to my Tools panel. I'm going to click on the Shaper Export button, Export to Origin. This only shows up after you've installed the Utilities plugin that's linked in the project, so note that. I'm going to open it. The input type by default should be single solid body. One trick here if you go over to the feature browser on the left and open up this bodies folder, there's two bodies, pins and tails. We're going to need both of them, but it's kind of hard to get exactly what we want here with them both open. So if I hide the pins, we're going to export the tails first. That's what's visible. I'm going to select this surface, so the surface below the top of the pins, and hit OK. And that is going to ask me to save. You'll note that the file output name matches the body name, so it's helpful that that's named tails and that you use the dovetail mill to go after it. And that should help you when you're placing files on Origin. Cool. So that's saved, and then we're going to go ahead and hide the tails now and do the same thing. Export to Origin, surface below the top. OK. This one's named pins. We're going to save it, and we are there. OK. At that point, those files are ready to go ahead and upload to my Origin files on ShaperHub, or put on a thumb drive and stick on your Origin at home. And with that, I'm going to turn it back over to Jake to actually get to the good stuff here and get cutting.
All right. Thank you so much, Noah. I really hope everyone understands how exciting this generator is. It is it's amazing, and to be able to cut such fantastic looking dovetails with Origin feels like a real win. So I've gone ahead and milled up some material. I got some 1/2-inch thick cherry, about 6 inches wide, and glad he remembered all the dimensions. It worked out perfectly. And I'm going to use that 14 degree dovetail bit, just so everyone can see what that one looks like. That's the one, that 8 degree. Come over here. That taller 8 degree, we'd use that for a piece of 3/4 material. But for right now, we're using that right there. Okay. So I have done most of the legwork already, but we're going to cut both the tails and the pins. I'm going to cut the tails first. One, because it's the scariest part to do live on camera, and I want to make sure I get it right. And two, because I want to use it later on to test my fit on my pin section. So I'm going to go ahead and get this into my workstation. Again, as always, if you want to come down here, Goose, pressing firmly against my register pins, firmly against the support bar, and then I can tighten my clamps up. Now I'm just checking on this edge of my material over here, because I marked that with a little X. That X is telling me, okay, that's my reference edge. I want to make sure that when I cut the bottom and the top, I am using my same edge pressed up against my pins. And that just helps with alignment later on. If you're familiar with the process of box joints, I say that over and over again. Always use your reference edge. I'll scoot that up just a hair. And good. Bring that down. And for right now, I'm going to give it a little gap like that. Start with a new scan. Now, I already have workspaces for this, but I want to walk you through the process of creating kind of a collection of workspaces, especially if we're doing something like creating a set of drawers. We want to be able to jump to and from multiple workstations as we need to. So a workstation for the pins section, and a workstation for the tails. It's going to make your life a lot easier when you got pieces of...
Jumping in for a hot second, I think you mean workspaces, not workstations.
Yes, I do. Wow.
Yeah.
They know what I meant.
Not saying that you need to buy multiple workstations, though you could.
You could, yeah. Just leave them all set up. Hop down into grid. Start a new grid. Of course, I have my engraving bit chucked up, finger tight, backwards into my collet. So I'm going to use that as my solid 1/4-inch probe. Come down, set my depth. Bit size, correct. There we go. 1/2-inch grid works great for me right now. So I'm going to come over here, Bada bing. And finally, on that left edge. Now, back up into Scan, into Workspaces, and I'm going to rename that Tails. In this case, I'm going to just do 2. So that's my tail section. Duplicate it, because we're using the same material all the way across. I'm confident that my material is consistent. So rename that to be pins. 2. Okay, let's focus on the tails first. Bring in my origin file that came from the plugin. Going to use that center left anchor point. I want to point something out before I place it. Notice how it overshoots slightly on that right-hand side. That's because I want it to be equal. That's why I set up a half-inch grid. I'm going to pop it over negative 0.5 on my x direction. And I'll show you why. That allows my half-inch cutter. It gives me extra space on the ends of this design so that I can get my half-inch cutter in there. Otherwise, Origin thinks it won't fit. This just kind of overshoots it just enough so I can get in there.
And I'll just jump in here really quick, Jake. So, and when I said we won't talk about it, I guess I lied. So that last parameter that I was talking about, Goose, if you want to just quickly jump on back over to my screen here, that last parameter, this edge overcut value right here, that's what Jake is actually referring to right now. So basically what you want to do is take this edge overcut value, so whatever you set it to, the default is 0.5 and you can leave it there, it should be fine. But you want to take that value and you want to move along your x-axis one grid increment. So that's a half-inch grid increment, but you want to match your grid increment to this edge overcut value. So if you change this edge overcut value, you need to change your grid setting, your increment setting here to match. On Origin rather, to match this setting here, so that everything lines up evenly, because it's relying on you to do that so that the dovetails are aligned on the center of your board, which is important if you want things to line up. Back to you, Mr. Jake.
All right, that was a good moment because it gave me a chance to throw my dovetail cutter in. And now that I've put a new cutter in there, I am going to tell it that I have a half-inch cutter. Yeah, 0.5, good. And I want a Z-touch directly on that edge of my cherry. Hands off the tool, let it do its work. And if you pop down here to this camera real quick, Goose, I just want to show how I position my support bar, especially when I'm touching off. I want to make sure that the back of my Origin is on the support bar. But I'm going to move this back when I start cutting because I want to give myself plenty of room here to move through as I'm cutting through these pins and tails. Okay. Oops. So given that we're doing this in a full pass using that dovetail cutter, I'm going to give myself a little bit of wiggle room. I'm going to do a larger offset for my first pass. Oops. That gives me a nice buffer there. Also, before we start, look at the geometry of this cutter. That's my material up there. My support bar is way down here. This is my safe zone. This is where I'm plunging and retracting. If I do anything in here, or even here, I'm going to take off the tip of that tail. So this is my safe zone to plunge and retract.
Yeah. Maybe, Goose, you can bring that slide back up really quick just to kind of double down. This is
really drive that home.
This is really the only important thing. If you learn one thing today from this session, it will be this. Please. Only retract and plunge in the safe zone. Otherwise, you'll be unhappy. Yeah, so move out in front of your material fully, plus a little bit, before you press that red button, okay? Don't do it. You won't like what happens if you press the red button while your cutter is anywhere near your work.
Yep.
Or the green button for that matter. Plunging is the same deal.
Yeah. Okay. I'm going to run through this once with an offset. I'm going to come back, cut it to 0, and turn the origin on.
Cool. So while Jake's cutting, I'll just go ahead and be pedantic here one more time. He's plunging well outside of his material, okay? And now he's going to go ahead and cut through. Jake has put a good offset in there to come through and cut this out. So the file is going to import natively as a pocket. That's just sort of the nature of the way I built it and the way that the Shaper Utilities plugin exports it. You can pocket it. You can set it up as a profile with an offset. It kind of all depends on how big your tails are. If they're really big, you'll have to pocket some part of it. And that's okay. I also want to point out here, Jake is just going after it. He is not using an end mill to clear out any area. He's just going after it with the dovetail cutter, and that's perfectly acceptable. Origin can handle it. I would say here it's good to experiment with your feeds and speeds. We can ask Jake what he's using here with this cherry when he's done. But what's important is that you are careful. If you're taking a lot of material off in a nice piece of hardwood, and say your cutter's a little dull and it's getting hard, that is a recipe for retraction. Okay, so you want to go slow. You want to be methodical. You want to use a nice sharp cutter. You want to keep that cutter clean with solvent so that you get the pitch off of it. And then you should be okay to go ahead and just not try and deal with using an end mill to clear this out, because it is going to be complicated. And I'll stop here for 1 second. Jake's reset to 0, so he's now cutting to 0. And we'll talk about how you get the fit of these perfect. We're going to adjust the fit on the pins because that's going to be a little easier for us to dial fit on the pin side. But what's important here is that if you do decide to use an end mill to clear area out, the tails file is built to use the dovetail mill of the diameter that you've specified in the generator. So you got to do some math to make sure that you've offset enough that you're not using the end mill to cut into any of your overcut. So you need to offset by the greater than the radius of your dovetail mill in order to clear those undercuts. So greater than the radius. That's really important if you're going to use an end mill to clear out some of the rest of the pocket. All right.
We did it. There it is.
Yeah. Did your butt pucker?
That is our tricky section. And I'm so thankful that
that's what I probably inappropriately, but I like to call that the butt pucker zone.
Oh, yes, very much. so tense the entire time, but mostly it's just because I'm on live. And I am very happy with the results. I said I did the other side already, so we can go ahead and switch to. I love that. Switch to our pin section. Same size material. Looking for my reference mark. Okay, it's on this side. That's going against my pins on my workstation. But here's the tricky part with the pin side. It is not as reversible like the tail side or like a box joint, so I can't just necessarily flip it like I want to still use that same edge. I need to flip it and twist it in order for the file to work. So instead of using that same reference edge, which is now over here, I'm going to create a new grid on the right side of my material and base it off that proper reference edge. And again, that is just to make sure that all top or bottom lines of your box are going to line up nicely. So let's go ahead and do that. Same deal. Pop that up there. Bang. Reference line over here. And clamp into place. Give that the old field test. Feels good to me. All right. Let's go ahead and swap our cutter out for our standard 1/4" end mill. The stock one in the box. And I'm going to do a little cheating for time's sake. I am going to recreate that grid using the solid portion of my 1/4" end mill. So I'm going to actually dive pretty deep when I'm gridding.
Jake. You can actually show the little trick at the last probe of your grid. If you hold the button down
and
move away from the surface, it won't scar it up.
That's right. That is right.
Yeah. So what's going on, Jake? Instead of the way that we recommend that you make a grid is to turn your engraving bit that comes in the box upside down and use the shank of that as a pin to
Just
align
like
things
so.
to. Yeah. But if that sort of is costing you time that you don't want to deal with swapping those bits in and out, it is okay, as long as you're careful to plunge all the way down so that you're hitting the shank of your end mill, so you're beyond the cutting geometry of that guy, and use that to align. But when you click the last grid point, the tool will retract automatically, and it can leave a little scratch at the side of your material. But Jake will show you how to avoid that.
Put this out of here for right now. Plunge it down. Set my depth. All right. First one. Second one. And again, coming around on the right side, pressing, holding down as I move away. Now I can lift up safely. I'm not worried about the flute marring the edge.
Yeah. So as long as you hold the button down on the last probe, that will work.
Back into import, we're going to grab our pin section, and instead of using that left center anchor point, I'm going to grab that right center. And at this
Jake,
point,
why is that?
Why is that? Because that's
yeah. Why are you using the right hand side?
Oh. Why am I using the right hand side?
Why are you lining off the right hand side? You should talk a little bit about that.
The right hand side is where my reference line is. So down here, instead of using the points like on the back side of this piece, I would use the left hand side. And because I have to flip it and twist it, I want to use the right hand side so that I'm aligning everything off the same side to keep it consistent.
Yeah, and you have to flip it and twist it because the pin side is not symmetric, right? It's matching the dovetail profile at 90 degrees. So if you, maybe zoom in on the top of that guy on one of your cameras, Jake, if that's possible to do. You can see that if we come at it from the top, we have to sort of turn it over one way or the other. And if you turn it over, flipping it like we would end to end with a box joint to keep the reference edge to the left, those sides would be reversed from one another, which would not work very well.
Nope.
So what Jake's doing here, which is a little bit of a clever move, is he's marked his reference side, and wherever that side goes, he follows it with his grid. And so this box joint generator has been made so that you can align on the left edge or the right edge. And for the pins, you're going to want to take advantage of that if you want to keep your reference edge constant.
Yep. Put that back on. All right, and placing at 0, 0 in this case. In this case, we don't have to worry about the extending the left and right like we do with the 1/2" cutter, because we're just using our 1/4" cutter.
Well, and also the pin side does not extend all the way beyond the edge, right?
Yes, it's more captive. 1/4", course, I want to Z-touch directly on top of that cherry. Hands off the tool, let it do its work. Boom. Keeping that same depth, I'm going to do a little pocket first and then come back in and cut my interior. And just looking over it, everything looks nice and good. Okay. Pardon me while I cut this.
So the big deal that we made about the dovetail cutter does not apply when you're cutting the pin side, because you're using a vertical, straight, square end mill. So it's okay. You can sort of plunge and retract wherever you want. You can see Jake's sort of doing that at will. He's going to come through and clear this area out. He is going to do that because there would be little sort of triangular slivers left on the wider ends of those with the 1/4" end mill in this particular size. So it's good to clear those out first. We like to pocket before we profile. It just means that you're just sort of skimming off a little bit of material when you go to your inside cut at the end, which is nice and leaves better cut quality, and it sort of leaves less room for error. So that's not necessary, but that's how we do it. You'll also notice if you place these files, actually on both of them, and I noted this in the design, or in the project rather, there's sort of an erroneous outside cut line that the Fusion Shaper utilities for Fusion adds to this file, and there just ain't nothing we can do about that. Just be careful not to cut it, to plunge on it. And in fact, one thing that I like to do with lines that I know I don't ever want to cut, or potentially don't want to cut for a while, I just go ahead and hover over them in cut mode, tap on the cut type, which will is the button second from the top, and change it to a guide. And a guide will not allow you to cut if you hover over it. You can interact with it still on screen, but if you click the buttons while you're over it, you won't be cutting on top of it. So
I just want to
back
pause
to
real
Mr.
quick.
Jake here.
I want to pause for a moment before I cut my final depth, because I want to just take the opportunity to take my tail section, line it up, and just give it a gander and make sure, in this particular case, I can't test fit it directly. I can't actually press it into the joint, but I know that I can see visually that I need to take that last little bit off. I'm going to do my finish pass, and we're done.
Yeah, and that may be a change I make to the file over time to flip that around so it's easier to test fit your joints. But easy enough to, before I've done that, or if I've forgotten about it, to just mirror the file in Fusion, if you're careful about it. What's going on there, the problem is that it's the angle that the file is generated from. And so you'd have to mirror the parts in order to make that, make it so that the open, or rather the end facing you while it's clamped in the workstation would allow you to fit while it's clamped. But if you're overcutting by a little bit, which is something we should touch upon in order to make your joints proud, that's going to be problematic. So we'll talk a little bit about this, but it's okay to miss and make your joint a little bit too tight and unclamp. Workstation, especially if you're using Workstation, Workstation's alignment features are really reliable. So if you have to take it out, test it, and it doesn't end up working, well, that's okay. You can pop it back in Workstation, carefully aligning. This is why you should always be careful to align and grid, and means it's sort of your get out of jail free card. You can put it back in Workstation using the same alignment, careful alignment that you did before, and you should be able to come back and machine a little bit of material off it and make the fit better. Jake, are you excited?
I'm very excited. I'm just making sure that all my X's are lining up correctly. Let's take a little bit of forethought here. And start setting my joints. X on this side. There we go. A little tap tap. So exciting. Boom. And the final piece, X's. X marks the spot.
Hey, you got it all lined up. That's a little bit of a puzzle because these joints are asymmetric. You want to have your wits about you as you clamp up and set up these cuts, because it's not quite as simple as a box joint where sort of anything will go with anything. Look at that.
Dovetail box.
So how easy was that, Jake?
It was not only easy, it was fun.
Jake's been scared of doing dovetails for like years, I think.
Yeah.
And so it was actually like my personal challenge in all this to show him that it actually was easy and quite enjoyable. The only unfun part was trying to figure out how to make the file, and we've dealt with that. So
yeah. And I love that I'm not tied to this shape of material or this style cutter. Like if I decide, even for aesthetic reasons, that I want a lesser degree in my taper, I can do that. I feel like I can do dovetails on anything now. It's great. All right.
So if you maybe want to push in on one of those joints, Jake, on your detail camera, we can take a look at it. One thing that I did want to talk about a little bit is overcutting your joints so that you end up with a little bit of material proud. Jake did not do that today, so he built these so they should be just pretty dead on flush, which is great, and all of sort of the gods willing, we end up flush. But sometimes little indiscretions here and there, say the end of your board isn't cut perfectly square, will cause some undershoot or overshoot. Overshoot's good if it's a little bit. Undershoot ain't good. And so one thing that you can do to kind of right, exactly. It's not really possible to add wood. It's pretty easy to remove it. So one thing that you can do is overcut the joint, and you do that by adjusting the depth of cut that you cut this to. So Jake cut this to his material thickness, which he measured with a caliper beforehand, by the way. And I strongly recommend that you do that and input that into the file, not just the depth of cut in Origin. You want to put that dimension in the file. And I can't stress this enough. The depth of cut in your Fusion file needs to match the depth of cut on Origin. Doesn't really matter for the pen side. Well, kind of does. It kind of all matters. Just match it. Because what we're doing is we're dealing with angles here. On the dovetail side, the deeper that cutter goes, the wider that the angle is going to be. That's just the nature of a taper angle. And so if you want to overcut your joint, I recommend that you add the amount that you want to overcut your joint by to the Fusion file and to the Origin depth setting while you're cutting. And you don't need to do it by much. I wouldn't do it by more than maybe like 20 thousandths. You don't want to go crazy because then you'll start to really eat into the dimensions of your project. So it could be even less than 20. You could do 10 thousandths and it would probably be fine.
Yeah.
You could probably do 5 thousandths and it would be fine. If you're careful and your cuts are square, you could do 0 like Jake did and it looks great. But just know that is an option. And now you know.
Right on. Thank you for everyone for joining us on this joyous journey in Dovetails. And
yeah,
really appreciate it.
Yeah, totally. And so basically this file, obviously you can see Jake's got a 4-sided box. Doesn't have a bottom, doesn't have any other features in it. So yeah, exactly. What you do with this file is up to you, right? As Jake mentioned, it is a file that is very adjustable. It is a file that can be updated to suit the needs of your project. hopefully I did it right, and you don't break it. But feel free to let us know if there are problems with it. But really do, and I put in the notes in the file, check your work, check my work, test it out. Don't just start in something nice, because it is potentially a little confusing at first. But what's fun about this is literally just the joints. So the rest is up to you. You can use OnTool CAD to cut dados for drawer bottoms. You can go back and look at our OnTool CAD joinery session to see how that might be done. You can cut pulls in it for doing drawer pulls. You can cut slots, dados in the outside of the box for drawer slides, all sorts of things. This is really just the generator for joinery, and the rest of the project is sort of up to your creativity. A drawer could absolutely be made pretty easily, and the rest of the parts you could probably cut with OnTool CAD. So
Thank you, everyone, for joining us on this evening for Origin and Dovetails, and see you next session.